Hi, we will be doing energy and work done for this particular chapter. So first of all, what is energy? Energy is the ability to be able to do work, and the SI unit of energy is in joules. How can you write joules? Is basically a capital J. So in exam, if let's say they ask you to name the SI unit, you have to spell in full, which is the SI unit for joule would be energy would be joules. If they are asking you to state the symbol for the SI unit inside. Now, there are many different forms of energy. The first one that we are looking at is actually light energy. Now, what is light energy? Light energy usually comes from a main source, which is the sun. And that even not the sun, but a normal light bulb would also be able to act as a source to provide light energy. So light energy is basically that energy that enables us to see things around us. Without the light energy, we will not be able to see things clearly, and at the same time it will be quite dark. How do we actually, another word that you may come across is called luminous. Luminous means being able to release light on its own, and generally with the ability to do that, you will be able to see it, see things. So as of now, sun is really the main source of light energy. Next, we look at the second type of energy in the form of heat. So anything that that results in an increase or decrease in temperature, right, is due to heat, and that heat is generally the energy that flows from a region of high temperature to a region of low temperature. So this is how heat energy travels. So second thing is there are three main methods in which heat energy can be actually transported. They are your conduction, convection, and radiation. This comes in as a separate chapter on the effects of heat. But just a recap, conduction is mainly the transfer of heat energy through the passing of the medium. That means, right, the one particle will be able to transfer the heat energy when the first particle will collide with the second particle. So this collision will result in a transfer of energy without the medium actually moving. It is still able to vibrate about its fixed position or just heat about its height. So this is for conduction. Convection is whereby it is due to the transfer of heat energy whereby the medium, okay, the particle would actually carry itself to that particular location. So you will imagine one molecule to actually move to the other side, okay, to transfer that heat energy. So the other can actually move around, and there are of course other series of things that actually result in the direction of how this heat is transferred. And last but not least is radiation, where the particles will actually be able to emit its own heat energy across a vacuum without a medium involved, okay, and that's how we actually get heat energy from the sun. Next, we look at the third kind of energy, which is sound energy. So sound energy is a vibrational kind of energy where it usually occurs when objects actually vibrate. So let's say a drum, when you hit the drum, the skin of the drum would actually vibrate, resulting in sound energy being produced. Electrical energy is the energy produced through the flow of electrical charges. So common things like your electrical appliances or electrical plug, those are the ones that will provide a source of electrical energy. And usually metals are a good conductor of electricity. And number 5, this is important, which is commonly asked, what is kinetic energy? So kinetic energy is the amount of energy that an object possesses due to its motion. That means moving energy. Now the formula to actually calculate kinetic energy is half times mass times velocity square. So in other words, kinetic energy equals half mv square. Now what is mass? So mass is basically the amount of matter the object has. V is velocity. It is basically the speed, but velocity, it takes into consideration the direction of the speed of the object. So these are some things to take note of. And as long as something that's moving, it contains kinetic energy. Next, we have potential energy. So potential energy is the opposite of kinetic energy in that it is an example of stored energy. Usually it is calculated through mass times gravitational force times height. Okay, in which your height is in meters, your mass is in kg, and of course your grams is your g is actually your gravitational force, which is 10 Newton per kg. Okay, we can even further break up potential energy into three main types. You have your gravitational potential energy. This is potential energy due to gravity, and on Earth it's a very standard of 10 Newton per kg. The value this one you have to remember. Chemical potential energy, this is the one that is generally found in maybe food or fuel or even your battery. Energy that is stored within the chemical form. Okay, and then of course you have your elastic potential energy, which is energy that is stored due to the compression or stretching of a spring. Like when you pull a rubber band and then let go. So when you pull the rubber band, you actually start to store elastic potential energy, and that's why when you release the rubber band, will retract, it recoils, converting to kinetic energy. So some main source of energy are generally, number one, solar energy, which is mainly energy coming from the sun. Biomass comes from the word bio and mass, where bio is generally living things, mass is basically the amount of matter it contains. So biomass is basically the source of energy from maybe organic material. And then last but not least, you have fossil fuel. Fossil fuels are able to be obtained like a petroleum, where after your dead organisms being compressed and by large pressure and things like this, it becomes petrol. So that's fossil fuel. So some other source of energy can also include geothermal energy, wind, water, wave tides, and radioactive substances. So there are a lot of different sources of energy. So if we break it further, so solar energy is basically energy directly from the sun. And what is the value of having solar energy? This helps to actually enable plants to be able to make food and animals to live. Solar energy is also easily convertible to other forms of energy, for example, light, heat, and even electrical energy, like your solar panel. And solar energy tends to be a renewable energy source. Renewable meaning that it can be reused. Biomass, on the other hand, is basically organic material made from living or recently living organisms. So biomass, they tend to store all this stored energy within it. And where are they from? They generally come initially from the sun. So after the process of photosynthesis, which converts light energy into chemical potential energy, all this chemical potential energy is then stored within the biomass. So biomass is another example of a renewable energy source. However, its supplies are not actually limited. So what you can do whenever you use finish, let's say the trees as a source of biomass fuel energy, right? You just have to replant the tree only. So it tends to be renewable. Okay, so what are some of the processes where such biomass energy can actually be used for? There is combustion, which is the burning of your fossil fuel. Burning of your biomass to generate enough steam to help to turn the turbine at the electrical factories to generate electricity that can be used for home, like for heat and any other purposes. Decay of organic material is another example where through the decomposition of dead organisms or organic waste, you can actually produce methane. Methane is a form of a gas, okay, which can release heat and light when you burn it. Then of course you have fermentation. This one is from yeast that helps to actually fermentate sugar to produce ethanol. And ethanol is another kind of organic fuel, fossil fuel that can be used for combustion, or even for your transport system. Okay, next is fossil fuel. Fossil fuel, there's three main categories. They are your coal, natural gas, and oil. So basically, with all these three, right, within it actually stores quite a lot of chemical potential energy, in which when they are burned, they tend to be able to convert from one form to another form. Some of these forms are, for example, light and heat. Now, however, there is a major disadvantage of using fossil fuel, in that they actually can result in causing air pollution and global warming. Why air pollution? Some of these fossil fuel can undergo incomplete combustion, resulting in the production of carbon monoxide, which can be used as a form of air pollution. If you burn fossil fuel, you combust fossil fuel, you will actually produce carbon dioxide gas. And carbon dioxide gas will then add on to the greenhouse gases in the earth, and hence will result in hot air not be able to escape out of earth. It will lead to global warming. Another thing to note is that fossil fuels, they tend not to be an example of a renewable energy source. Instead, it's actually a non-renewable energy source, meaning it takes a lot of time, too long of a time, to be able to replace the amount of energy that we use. Then comes the next most important one, which is the law of conservation of energy. This one, please remember it for exam. It's commonly tested. And what does it actually entails into? So the law of conservation of energy indicates that energy cannot be created or destroyed. And what this actually meant is that they can only be converted from one form to another form. So that's an energy transformation. And that's what when you don't lose or gain energy in the form of from creation or being destroyed, the energy is always conserved. That means it's not lost. Okay. Energy can be changed from one form to another form. For example, if you use a hairdryer, okay, when you plug into the electrical socket, the electrical energy can be used to generate or convert into heat and sound energy. Heat so that you can dry your hair. Okay. And then sound, of course, these kind of instruments are never quiet. Then next, burning a candle, you are converting a chemical potential energy to the form of heat and light. When you put your hand near the candle, you feel warm. And of course, when you see from a distance, the candle is actually, there's a flame, it produces light. Roller coaster, you will always start from the top highest point, so you will have the highest gravitational potential energy, and definitely when you go down the slide, you will increase in kinetic energy. Okay, so there's this conversion. So when we look at this example, a ball is released from row A, from point A, and it rolls down to the slope at B, and then goes back up again. So what form of energy is possessed at A? At A, because you're actually positioned at the highest point of this particular height, you tend to have quite a high value of gravitational potential energy. Okay. And then slowly, when you move downwards to the ground, what will happen is the kinetic energy would actually increase, such that the potential energy is converted into kinetic energy. Okay. So here you have kinetic energy, and slowly at C, you have your kinetic energy converting it back to gravitational potential energy. However, you see that C doesn't go as high as your original A. It's because along the way, when kinetic energy is converted to potential energy here, there are energy that is lost in the form of heat and maybe sound. So this kinetic energy is again not converted to potential energy in full, but mainly some can actually be escaped as heat and sound. So with these, energy sources can be classified into two main areas: renewable and non-renewable, where renewable energy sources are basically energy sources that can be replenished, can be replaced over a short period of time after they have been used. Like if you cut a tree today, you can just grow another tree. However, the time for the tree to grow up is another major consideration. Another one is non-renewable energy sources, sources that cannot be replenished in a short amount of time. For example, your fossil fuel, it takes thousands or even millions of years to get the fossil fuel, and you can't really speed up time that fast. So this is why fossil fuel are considered as a non-renewable energy sources. Okay. So there are some examples from this table. You can actually try to remember some of it. And the energy plays a very important role in the human and our everyday life. In that we really depend on all these things. Imagine one day you don't even have a Wi-Fi, just because there's no energy to supply that amount of technology. Okay, to run your satellite, to even like to battery up your phone and things like this. So most of this energy used in the surrounding is supplied by non-renewable sources, made like your fossil fuel. So only when fossil fuels are used up, they cannot be replaced quickly. That's why it is estimated that the supply of fossil fuel, right, like a petroleum and natural gas, can maybe at most last you another 50-70 years. So we are now trying our ways to leverage on other forms of energy and to reduce fossil fuel usage. Okay. Therefore, it is important to conserve energy so that reserve of fossil fuel can supply enough for a longer period of time, because there are also other areas which you still need fossil fuel to generate enough energy. Okay, so that's why we must also learn to conserve energy. Okay, so what we have just done is to went through the idea of energy, what are the different types of energy and the conversion. Later on, we will be discussing more on work done as well as power. These two areas is how we are able to use energy over a period of time. Thank you.